So we have done a whole bit, well, 4 different methods of factoring in this unit. Done 4 different methods of factoring within this unit. Today we're going to do the last one. Well, let's look at where we've been. So, first one is greatest common factor. Again, it's anytime, anywhere, any place. Anytime, anywhere, any place. So greatest common factor is biggest number, same variable. And you use those two to get your GCF. Some of you are real good with it by now. Some of you still can use a little work. So you know what mode that you're in. Grouping, you must have 4 terms. Grouping, you must have 4 terms. So grouping, so 3n squared plus 9n plus 5n plus 15. Take the first 2 groups. First 2 make a group, last 2 make a group. Factor it out. You should get, if you do it correctly, you should get the same thing in parentheses. If you factor this out the right way, you should get the same thing in parentheses. That's grouping. MAF. There are 2 types of MAF. There's MAF when A is equal to 1. There's MAF when A is not equal to 1. MAF when A is equal to 1, x squared plus 2x minus 8. So A is equal to 1. That means you can directly do MAF and solve it out. If A is not equal to 1, 2x squared minus 3x minus 5, that's when you have to do A, B, and C, and then change it to M, A, F. So that's the longer version that we did all of last week. The longer version that we did all of last week. So those are the 4 types that we've been doing since we've gotten back from spring break. So we've been doing factoring since the first week of April. Here we are the first week of May. Again, next week you will be taking your test on factoring. We are moving out of factoring. We're moving out of factoring. So, there's still one more method that exists. The last factoring method involves expressions with 2 terms. 2 terms. This is a special method because both terms must be perfect squares. Both terms must be perfect squares. So you are working with perfect squares. You are working with perfect squares. So perfect squares we did all the way back in chapter 1. So this chart is a chart of perfect squares. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square. 2 times 2 is 4. 9 is a perfect square. 3 times 3 is 9. So on and so forth. So at minimum, you should know the first 12. This goes to the 15th perfect square. But at minimum, you should know the first 12. However, you must know how to use perfect squares in order to factor using what's called the difference of 2 squares. The difference of 2 squares. So, difference of two squares is the name of it. The name of this method is difference of two squares. In order to use it, you must have two terms separated by a minus sign, and both terms must be perfect squares. Perfect squares means there is something times itself that will give you that number. Something times itself has to be able to give you that number, or that variable. So, here's a couple of examples of problems that would work, and here's a couple of examples of problems that would not work. So, these two examples are yes examples. Why? M squared minus 100 works because m times m is m squared. 10 times 10 is 100. And you've got a minus sign in the middle. And you got the minus sign. The second one also works. Because 3 times 3 will give you 9. P times P is P squared. 7 times 7 is 49. And you got a minus sign in the middle. So it all works. Everything's a perfect square. So, any questions on why those work? Because on your homework for this section and on the test next week, there will literally be problems that will ask you, can I use difference of two squares to solve this? You're going to have to tell me yes or no. And if the answer is no, you're going to have to tell me why. It's not some garden variety of just solve it. No, there are some problems in which you're going to tell me why. Why doesn't it work? So here's some no examples. N squared minus 40. Well, we got the minus sign. We have two terms. We've got the minus sign. N times n is n squared. But is there something times itself that will give you 40? There ain't two numbers, any number times itself that will give you 40. No. Because if it was, it would be in this list up here. There's no 40 sitting up there. So something times itself that gives you 40, no. That doesn't work. That second problem also doesn't work. Yes, you have two terms. But you got a plus sign. That's an automatic failure. That's an automatic failure. It's difference of two squares, not sum of two squares. There's no such thing as sum of two squares. You can't use difference of two squares unless they are both two terms, minus sign in the middle, both of them perfect squares. So any questions on why the first two work and the second two do not? Again, those of you at home, don't be shy. Be shy all you want during the summer. Right now, if some of you don't understand, you need to ask. If you know you're fighting to try to get to a particular grade, you gotta ask. Yeah, remember, you have two quizzes left. The one that's due tomorrow, and one more. And you have two tests left. That's it. Running out of time in these streets. course, hopefully you're copying your notes as well. All right, so here's how we do difference of two squares. Again, the first two examples I wrote out, so all you have to do is watch, follow along, and ask questions if you need to. The first two have already been done for you. The fact using difference of two squares. Step one is always take out the GCF if it's greater than 1. So m squared minus 100, biggest number is 1. They don't have the same variable, so your greatest common factor is 1, so nothing's going to change. Step 2, find out what to the second power will give you the first term. So the first term is m squared. Use my highlighter for this. So for m squared, you have to ask yourself, what times itself will give you m squared? The only thing that will do that is m. M times m gives you m squared. Then you do the same thing to the other part of the problem. To the 100. What times itself will give you 100. So that's 10 times 10. So we did step 1. Step 1 is GCF. Step 2 is the first term. Step 3 is the second term. Last term is to write your answer. Last term is actually write your answer. So, writing your answer, this is how we write the answer. So remember, greatest common factor always goes first. So if you had a greatest common factor, you take it out. So the m and the 10, you're going to write it in one parentheses with a plus sign in the middle. And then you're going to write it again with a minus sign in the middle. So here's why one of them is a plus and one of them is a minus. Positive times negative is negative. Look what was in the problem. A minus sign. So you get your minus sign. If they were both positive, a positive times a positive is positive. If they were both negative, a negative times a negative is positive. You need a negative. So that's why one of them is positive and one of them is negative. M times m gives you m squared. 10 times 10 gives you 100. So everything checks out. So that's why you write your answer in that way. Any questions? Look at example 1. No, Katie doesn't have any questions. He's shaking his head. Or do you have any questions? Okay. So the two gentlemen here don't have any questions. You got any questions at home? Let's ask.
What is the second one?
Because if you have two pluses, what happens if you multiply two pluses together? What's the positive times a positive? Is there a positive in the problem? No. So you can't have two pluses in your answer because you have a minus sign sitting in your answer. The only way that you can get a minus sign is by taking a positive times a negative. So one of them has to be a plus, one of them has to be a minus. So there's no choice in that. There's no choice in that. That's a good question. I'd rather her step up and ask the question than some of you all fall back and, well, someone else will ask it. No, you ask it. So let's do another example. So, first example didn't have a greatest common factor. This one does. Blow it up just a little bit, just to make it a little bit bigger. So the steps are still the same. So example 2, 18n to the third minus 98n. Take out the greatest common factor. Biggest number you can divide out is 2. They both have the same variable, so you take out an n. So your greatest common factor is 2n. So that's what you divide out. (18) divided by 2 is 9. N to the third divided by n is n squared. 98 divided by 2, 49. So you have 2n parentheses, 9n squared minus 49. That's first. Always take out the greatest common factor first. Go inside the parentheses. 1 times itself gives you 9n squared. So since there's two things, since there's a number and a variable, you do them each separately. To get 9, that's 3 times 3. To get n squared, that's n times n. So 3n times 3n is 9n squared. Do the same thing with the second part. 1 times itself will be 49. 7 times 7. So now we know what we're going to use. Now we can write our answer. GCF always goes first. So 3n and 7 goes in the first parentheses. 3n minus 7 goes in the second parentheses. So again, you must have 1 plus, 1 minus, because the positive times the negative is negative. 1 plus, 1 minus, because the positive times the negative is negative. Yes. No. So you wrote it as 2n, 3n minus 7, and 3n plus 7. That's fine. Either way works. Either way works. Any questions on example 2? We've done the examples that were already done for you. Now it's time to get into that work. We've done the examples that we've done for you. Now it's time to get into that work. So give an extra couple seconds for those people who are still copying at home. And then we're going to get into that work. trying to get into that work. So, example 3. We have p squared minus 36. So again, our steps are still the same. We work with the greatest common factor first. So you've got 1p squared and 36. What's the biggest number you can divide out? You have a 1 and you have a 36. 1. Do they have the same variable? No. So your GCF is 1. If your GCF is 1, there's nothing you need to take out. There's nothing you need to take out if your GCF is 1. So now we do the two parts. So for p squared, we need what times itself will give you p squared. So what times itself will give me p squared? P times p. The variable times itself. Simple enough. What times itself is equal to 36? 6 times 6. So, step 1, GCF. Step 2, the first term. Step 3, the second term. We're ready to write the answer. Answer time. So for those of you wondering what the A and the B mean, A represents the first term, B represents the second term. So GCF, there wasn't any, so we don't have to worry about it. First plus the second, so that's P plus 6. And then P minus 6. That is the final answer that gets that full credit. That's the final answer that gets that full credit. Any questions? Example 3. Shortcut it. It's not hard. Don't shortcut it. It's not that hard. Shortcut is not that hard. I know y'all see us taking these notes because he's going to upload them before 3 o'clock. And the 20 points that he needs, 20 points that a lot of people need. Example 4. 16y squared minus 9. So we're going to do it again. You have 16 and you have 9. What's the biggest number I can take out? 1. There's nothing that divides into 16 and 9 other than the number 1. So, do we have the same variable? No. Nope. So your GCF is 1. You divide by 1, it doesn't change anything. Divide by 1, it doesn't change anything. So let's start working. So we need what times itself will give me 16 by squared. Again, there's two parts. So 4 times 4 will take care of the number. Now what about the variable? Huh? Put the variable next to it. Just means you have to do them separately. All that means is you have to do them separately. Yeah, I'm showing it so slow and so methodical for those of you who know that you struggle can have a way to do it step by step. So let's do the other one. Morgan can help me with this one. What times itself gives you 9? Yes. Okay, so I'm going to repeat this again. I want you to think about it before you answer this question. What number times itself? So it has to be the same number. 3 times 3. What number times itself means it has to be the same number. You can't have two different numbers. So 3 times 3 gives you 9. That's a mistake that a lot of people are going to make. He just so happened to make it this time around. Guess what? Ain't none of y'all perfect either. I'm not perfect either. So we have what we need. We can write our answer. So unless there's any questions sitting out there, we're going to write our answer. Speak now and keep your peace. So we get ready to write this answer. All right, so let's write this bad boy. So, GCF goes first. There wasn't one, so we don't need to worry about it. A plus B is your first term plus your second term. 4y plus 3. A minus B is your first term minus your second term. 4y minus 3. That's it, problem over. It's not hard, it's just going to make you think. Yeah, you can't finesse math like that. Any questions before we go to example 5? Any questions before we go to example 5? If there's no questions, that means when you see this on your unit test next week, you should be able to answer it, get it right, no complaints and no questions. That means I know Shair and Luke and Jay and Imani, they're going to get it right, no questions, no problems. So, example 5. Same rule apply. It's just like you want to rep in a basketball practice. You have 8 and you have 50. What can I divide out of both of them? No, I can do better than that. I can do better than 1. The biggest number I can divide out of that, I can take out 2. Take out that good 2. Biggest number is 2. Do I have the same variable? Both parts have the same variable in it. Yes? No? Maybe so? I'm saying, no, my glasses are good. I'm just want my verification. So your greatest common factor is 2t. That's what you're dividing out. That's what you're going to divide out. So 8 divided by 2 is 4. T to the third divided by t squared. 50 divided by 2, 25. There's your greatest common factor. Any questions before we keep going? Yeah, it's not hard, it's just work. It's just work. Let's do some more of that work. So now we need what times itself is going to give us 4t squared. So if you have a number and a variable next to each other, do the number first. What times itself gives you 4? 2 times 2. So t squared is t times 2. Ain't that hard. Some of y'all just making it harder than what it is. Not that difficult. Don't make it harder than what it is. All you gotta do is exercise that brain. What times itself gives you 25. A number times itself, they give you 5. 5 times 5 is 25. So, instead of writing it out in words like this, those of you who know what you're doing, here's the other way that you can write that out. Underneath each number, put the 2 parts for the D. This is showing your work. If you need to write it out for yourself to keep everything on track, keep writing it out. No shame in the game. Answer time. GCF always goes first. So you have 2t plus 5 and 2t minus 5. Not hard. Good work. Not hard. Good work. Get all 3 examples back in the screen. And questions 3, 4, or 5. You did the same steps each and every time. Same steps each and every time. So, quick 30 seconds for those people who need to copy any part before we do example number 6. The difference of 2 squares shows up a lot when we do grouping. Difference of two squares shows up a lot when we do grouping. So what we about to do? Grouping. The equations will do the bottom. Grouping we're going to do today. All right, so example 6. What do you notice about the parentheses? What do you notice about those two parentheses? They're the same. They're the same. We're down to x minus 5. We're going to cancel out. We get x squared minus 16. So if the parentheses are already the same, take it out. Now, I'm about to highlight a part. That part right there. X squared minus 16. Think to yourself. What times itself gives you x squared? There's something times itself that will give you x squared. What times itself will give you x squared? X times x. X times x gives you x squared. If you don't know what times itself means, say something. Stop being quiet about it. What times itself means what times that same thing will give you x squared. So, what times itself will give you 16? 4. So the part that I just highlighted can be broken down some more. So x squared minus 16 is x plus 4 and x minus 4. That's your answer. That is your final answer. So difference of two squares is sneaky. Difference of two squares is real sneaky. It can just be sitting in a problem. You don't even know it. But if it's there, you got to break it down. If it's there, you got to break it down. If it's there, you got to break it down. Any questions on example 6? Lauren, any questions on example 6? All right. So that is what I think